Hello all, welcome to the next class. Um, from the previous class, what we have learned is how to implement linear regression with the help of all the theoretical knowledge that we have. Now, what we see is how to play around with the linear regression, how to build a linear regression model, how to use the data with respect to the linear regression model using Python. So we'll cover these topics in the current class. So if you have installed your Jupyter notebook, just in the Linux, or even if it is generally it could be your Spider or anything else, just go to the terminal. If you are using Linux, you should go to that particular folder and you can just type ls. If you see, there are all the things that are available in this folder would be displayed, and then you can just type Jupyter notebook and you will get a Jupyter notebook. Okay, so Jupyter notebook will be of this form. You can just click it and this will open. So we'll go through a line by line implementation of what we are doing here. So just get into the topics right away. So what the goal is to build a simple linear regression using pandas and the scikit-learn. So these two are different modules in Python that are available. So pandas is an important library in Python that's purely used for understanding the data related application. So if you want to visualize the data, if you want to change the data that is in the form of rows and columns, you usually work around with the pandas. And when you have to work around with the scikit-learn, you have to understand the basic ML algorithms that are in scikit-learn. How do we get the data from the scikit-learn, and how do we import those libraries and play around with it is kind of the play with the scikit-learn. So these two are the pretty much important modules we have. And when it comes to the agenda of this whole particular code, we'll try to understand how is pandas library, how to read data in Python using pandas, how do we use matplotlib to visualize the data, so what is exactly is linear regression, so how it is working here, and how do I interpret a linear regression model using scikit-learn, and what are some evaluation metrics that are available for regression problem. So we'll go through one by one. So if I just go and I can start from here. And these cells wouldn't help us, but so this is the first line of the code. We have matplotlib inline, which means that we are starting an inline function. This is purely to visualize the graphs like this in here in the screen itself. We use matplotlib inline. So so we are importing the numpy array. So if you have installed all the modules, numpy would be pretty much straightforward. This is one important library that we use, the numpy module, for all the operations in all the array related operations in Python. So what all the data that we are having, this will be mostly in the form of arrays, and numpy would help us out in order to play around with that. So we'll just import numpy as np, and we will just import the pyplot in matplotlib as plt. So when we write import numpy as np, so wherever there is numpy, we'll replace it with np. So if you want to start an array in Python, what we write is numpy dot array of something. That's how we declare. So when we import numpy as np, we are supposed to write it as np dot array. So that's the difference. So you have to replace wherever there is numpy with np. So that's the indication of this line, import numpy as np. So we'll run this, and if you run this, it's kind of imported. If you get some error in here, it does mean that you did not import any of these libraries. Then you should just go and check like how to do the import and all. So we just imported the data. So here we are using a data set with 2 columns containing the number of hours that the guys studied and the test scores the students have achieved respectively. So that's the kind of data we are using. And how do we actually read this data using Python? So in pandas there is we'll import pandas, and pandas there is a case of reading CSVs. We call it read CSV because the data that we have is in form of CSV. So if we want to look at the data, it is here, and the data looks like this. So we have hours of study and the test scores. I think it's not clear here. Let me just open it in Excel. Yeah. So if you see the data, so the data is of this form. So number of hours of study done by one guy, and the test score he has got. So for example, he studied for 32 hours and he got some test score of 31, and some other person has studied for 53 hours and got 68, and someone studied for 42 hours and he got 79. So this is some random data that is available, and we are just importing the same data into our regression module. Yeah. So yes, so we have taken our data, we have read that data. So this file is actually, it's kind of reading whatever we are putting in. So it is reading the given data. Yeah. So data that head. So what we are doing here is we are just trying to show the data, the first few rows. So we're just trying to showing the first few rows of the data. For that we use data.head. We have something like this. Okay. So yeah, now once we got the data, we have to figure out our xy. If we recollect our equation of linear regression, it is simply y equal to so if we just recollect the linear regression equation, if we kind of do it, then it is simply w equal to y equal to w0 plus w1 star x. So this is our simple linear regression equation. So if we want to get this equation, we should know the values of the x and y, that is the inputs and the outputs. So that's where we are taking. So the input here is our substudy and the output here is the test score. So that's where we take from the data. So here we have the data, of course, and data is the the declaration we have made. All the CSV data is stored in the form of pandas data frame in the variable called data. So now we have data, and we are just trying to separate the series of hours of study. So when we do this, all the columns of hours of study will be entering X. So this will contain hours of study data from the file given CSV. Okay, and if we take this, then this would contain test scores of the given data, test scores column of given data. So we are having that column here. So we are just trying to print the shape, so and also the type. If we print, if we run this, so sorry, I forgot to run this particular line of the code. Yeah, so if you try to run this part, so you have print x type is type of x, print x shape is x dot shape. So you have x type to be a pandas series. So if you have the entire pandas, this total thing is called data frame, whereas the only one column, if you consider, we call it as series. So x would be the panda series and its shape is 100, and even y would be a panda series, its shape is also 100. So x would contain all hours of study and y would contain all test scores. So we are kind of reshaping the array of x with we are not just taking it as a single value. We want to make it a 2D array with 100 comma 1 dimension, because if you want to fit it into the further part of the model, it is always good to have x in the form of in this form of 100 comma 1 instead of 100. So we have to do that reshape part. If we have single column, it is very much important for us to change the x to a 1D from the 1D array to a 2AD array. That's very much important. And now we are trying to just figure out all the test scores that are available. So we are trying to kind of plot the text. So you have hours of study on the x-axis and you have test scores on the y-axis. That's how you're doing, and you're trying to do a scatter plot. So for every x it will plot its corresponding y. So that is the that is called scatter plot, and this is how our data looks. Okay, so let me, I think I have run this, I have to run this part. So yeah, if you see, it looks like this. Okay, so now the most important part of machine learning is you have the trained data, but you don't have any test data that is available. So all the data that you have right now is basically it has full data, so you don't have new data with you. So what all the data that we have available, I mean, for every student we have the scores available. So how do we test if our model is working well? What we do, so if we have some data like this and if we don't know the data, what we do is we do a kind of splitting. So splitting in the sense, you have 100 data columns, 100 data points for x and 100 data points for y. So we will split according to the size 0.3, where we only take 70 points for the training of the data and 30 points we will keep aside for testing. So testing, why it is required again, so we don't have the information of the data that corresponds to the testing, right? So we don't have the new data available with us. So that's why we want to start with this and we want to consider the testing part. So that's why we'll remove the 30 columns or 30 data points from the given data set, and we'll make it x test and y test. So we'll remove that part and we only send 70 columns of the data. So this test size, whatever we have here, so this is the key. So if we have test size to be 0.2, then the data would be split as 80 and 20. If the test size is 0.1, then the train values would be 90 and it is 10. So it is giving the percentage of the split. Okay, so let's run this. So you're trying to split it and we'll just get the shapes. So just to understand what I'm saying, so if I split it with 0.2 ratio, if I run this again, then the shape would be 80, 20, 80, 20, because we are doing 20% of the split into train and text size. So we are saying the test size only to be 0.2 of the whole data. So 0.2% of 100 values is 20. So yeah, let's take 0.3 for better convenience and we'll take, okay. So yeah, linear regression using scikit-learn. So I mean, means when we have the modules called scikit-learn, we don't have to build the model, or we don't have to write those equations of all the derivatives when we have a pre-built library which is doing all that for us. So it is not necessary for us to build, but it's good to learn the theoretical knowledge of it, but it is not necessary that we should understand, we should write the code in Python with respect to all the derivatives. So scikit-learn has a pre-module called linear regression. So from the scikit-learn, sklearn is scikit-learn, we'll import linear model. From the sklearn library of the linear model, we will import linear regression. So this would directly give us the linear regression function of scikit-learn module. So importing linear regression function of the scikit-learn, we are directly taking the linear regression. So what we are doing here, we are doing an instantiate, which means that we will just start the model, we will initiate the model. That's what we are doing here, and fit the model to the training data. So if you consider all the parameters, all the libraries like TensorFlow or PyTorch or scikit-learn, the learner line_reg.fit is a very famous thing where you are trying to fit the model, the one that you have taken here, you are trying to fit this model to the available training data in order to learn the coefficients. So what are coefficients here? the coefficients that we are talking about are, if we reiterate the equation again, y equal to w0 plus w1 star x. So our aim is to find weights. So yesterday we have discussed like how do we find weights, what is. So the goal is to find weights. How do we find weights? Finding the weights is what we are doing here. So when we say fit, it will automatically find the weights. Yeah, so we'll run this. Yeah, so the model is successfully run. If there is some issue in this part of the code, then probably you're not, installing the sklearn module perfectly. If you are doing Anaconda installation, sklearn will be there by default. But if you are not doing with respect to Anaconda, then you need to install sklearn separately. Okay, so even this part of the program would run only if you have installed sklearn. Okay, cyclically. So when we fit the model to the training data, we kind of already got the model. Now what we will do is we will try to understand what is the intercept and what is the coefficient. Okay, so pretty much straightforward, right? The intercept, which means that the w0. So intercept that we are talking about, if we consider the equation again, I'll repeat the equation, w0 plus w1 star x. So w0 is which is similar to, if we consider this similar to y equal to mx plus c. So in this equation, c is the intercept, right, and m is coefficient, right? So we are trying to just fit in, we are trying to find the c, the intercept, and m, the coefficient, which means that we are trying to find w1 and w0. So that's what we are doing here. So the w0, when we calculate the intercept of the given linear regression after fitting, is 12.58 and w1 is 1.12. So now we understood what are these values. So now the linear regression would be y equal to w0 plus w1 star. Our substudy is our x, right? So that's what it becomes, 12.58 plus 12.58 we have here, and 12.w1 we have here to be put here. The new equation would be this. So this is how we have obtained w0 and w1. So all the theoretical knowledge that we have gained yesterday, from changing the learning rates, doing the iterations, all this part is being completed with this one line of the code, learning.fit. So this linear regression.fit would eventually do it for us. And instead of linear regression, there is one more thing called as SGD regressor. So if I type SGD regressor scalar, so you get a different model parameters called SGD regressor. So if you want to fit for more amount of the data, then you go for SGD regressor. What is SGD regressor? It's nothing but stochastic gradient descent regressor. So the current data that we are having is only of size 100 by 100. But if we 100 by 2, so you have just 100 data points and you have just 200 data points. So if we go to a bigger applications, or when we have more amount of the data, then linear regression that we are using here, this part would help us much, because we are not having any learning rate here. We are not deciding the batch size. We are just giving all the data to fit the model. But when we have so many samples, we will generally go for SGD regressor, and this is quite efficient because it has all these parameters to go in. You can actually define the loss function, which is squared loss. You can define the learning rate. You can define the batch size. So you can do all these things when it comes to the stochastic gradient descent regressor. So I would suggest please go through the implementation of the SGD regressor and try to understand how they are doing. I mean, I'm not particularly choosing this because this only fits 10,000 values, and training 10,000 values in this particular video would take quite a bit of time. So I would sincerely suggest you guys to try out instead of linear regression, you also take a bigger data, find a bigger data from the net or find a somewhat bigger data samples where you have 10,000 data samples, try SGD regression. If you have any questions, please reach out to me like how to implement this and all. But you can always try for SGD regression instead of linear regression and come up with the results. And that's one way to learn, how do we fit it. All the process is same. From the beginning till the end, everything would be completely same, except the fact that we change the linear regression with SGD regressor, and we kind of change the model parameters. So I would sincerely suggest you all, if you wanted to learn more on the regression, I would sincerely suggest you all try SGD regressor and get some more. You can find many online challenges, online course, online GitHub things using SGD regressor. So just go to them, try to implement it on your own laptop. Don't just copy the code, just try to rewrite the code. That would be a huge help. Okay, so now we have got W0 and W1 when we know the equation. So we are trying to predict. Yeah, so what is happening here? What's the next step? So the next step is you have a Y prediction and you need to predict how your linear regression is predicting on the data that which the model has not seen yet. So what it is showing, it is trying to fit the data for given X train and a given Y train, but it has never seen the data called X test. These 30 samples the model has never seen. Now we need to implement on these 30 samples, right? So we go here and we'll try to predict on the 30 data samples that we have, and now we got the Y prediction. Now what we do, we have Y prediction, which is nothing but Y hat. So yesterday we were talking about the mean squared error equation. So you have y cap minus y whole square, right? So you have that equation, right? So now what we are doing here, we are just trying to do the error by calculating the same here. We are trying to calculate the mean square error out of the same, right? So let me run this, and you get the value of 11, which is a decent error, and the accuracy is just 100 minus 11. So if it is 11, which means that we have so if we have 11, then error would be 11. So if we have 11, error would be 11.97, and the accuracy would be 100 minus 11.97, which is 89%. So we got 89% of the accuracy for the plots that we have. So we will try to plot the line again and see if we can see the line kind of fits the curve. It's not. There are some points here and here that it is not fitting because it's simply a straight line, and that's the reason we couldn't get an accuracy of 100, or 100 is never an easy case. Of course, we couldn't get an accuracy of somewhere around 85 or even 95 or even 94 because the data is a little bit scattered and the line could have been better, or instead of taking line we should sometimes take curve as well, like at least fitting something like this. So that's what happens here. So so that's the end of the code. So I would sincerely suggest you all to implement this code in your own laptops by rewriting every line, and wherever you get some kind of doubt or a question of like what's going on here in this particular line, something like that, we would definitely discuss tomorrow from 7 p.m. to 8 p.m. I have sent a meeting invite, the same WebEx we can interact. Today we had a great interaction for almost 50 minutes on look at some of the concepts that they were unable to get from the first videos, and they asked about that. So tomorrow we can reiterate these processes again. So just try to implement these in your own laptops, and if you have any questions we can all discuss from 7 p.m. to 8 p.m. I will share yesterday's class slides and this video and the corresponding GitHub link of this code. I'll share all the three via email. You can check them and get back to me if you have any questions. Okay then, see you. Bye bye. Thank you.